SaaS. With SaaS, we proposing scalable smart contract architecture by using microservices-based philosophy. SaaS introduced as a smart actors as a service. So let's see what are the smart actors and how we propose scalable smart contract architecture with smart actors and SaaS. Okay, these are the authors of this work. So Eranga Bandar, that's me. I'm the presenting author. Suping Lane, Peter Poetic, Sachin Shetty, Nalin Ranasinghe, Kasundi Soisa, Ang Wikio. With SaaS, we're proposing a scalable smart contract architecture by using microservices-based philosophy. SaaS is an alternative architecture for traditional imperative style monolithic smart contracts. Basically, most of the existing smart contracts follows imperative style programming with monolithic architecture. So due to this reason, they cannot really support concurrent transaction execution on the blockchain. With SaaS, we're trying to solve these issues. So we propose microservice-based scalable smart contract architecture with SaaS. Okay, I will give a bit introduction about me. I'm Erang Bandar, working as a senior project scientist at Remas, Virginia, USA. I'm involved with various projects on blockchain, distributed systems, cybersecurity, machine learning, federated machine learning, etc. So actually, our main goal of doing research is we always try to do research, make publications. We just not satisfied only with 10 publications. We always try to build production grade application based on our research. We have done several such works. We build blockchain platforms, machine learning platform, federated machine learning platform, distributed system applications, mobile based applications via based on our researchers. That's the main motivation of doing research. We always trying to build some production grade applications through our researchers. So this is my Twitter username. I am available on Twitter. If you want, we can contact via Twitter as well. Okay, let's look at some background information. So with SaaS and some blockchain related informations. So SaaS smart contract architecture built on top of raza blockchain, which is highly scalable blockchain storage. Raza is another research work we have done. Raza blockchain is a highly scalable blockchain storage which mainly support for big data, IoT, smart cities kind of scalable enterprise level applications. So raza blockchain comes with functional programming and actor-based smart contract platform, Atlas smart contract platform. These smart contracts built in Atlas, all the smart contract right on top of actors. So instead of traditional class-based imperative style architecture, we use actors to write smart contracts. I will explain what are the actors and how we have adapt actors and functional programming into Atlas smart contracts in coming slides. So due to this reason, we introduce it as a Atlas smart actor platform. Since smart contract right on top of actors, we introduce it as a smart actor platform. So Atlas support concurrent transactions on blockchain using actor-based concurrency controlling. We support concurrent transactions by using Atlas smart contracts. So in here, what we have done with SaaS is we modified Atlas smart contracts with using microservice-based philosophy. In here, Atlas smart contract, all the smart contracts run on single monolithic container. With SaaS, we decompose independent smart contract into separate services. So and they can run on independent services such as on top of Docker kind of environment. So due to this reason, SaaS introduced as a smart actors as a service. I will give more information in coming slides. So first, let's look at some information about the raza blockchain. The raza is a permission blockchain environment which mainly target for highly scalable concurrent enterprise level applications. So it supports requirements of the scalable application, basically big data, IoT, smart cities, kind of enterprise level applications. So with Raza, there are three major contributions that we have done. So we propose some novel blockchain architecture to support real-time transaction. It's called validate execute group architecture. It's an alternative for traditional old execute based systems. So with validate execute group architecture, we can achieve real-time transaction on the blockchain as well as support lightweight consensus. And we propose functional programming actor-based concurrent smart contract platform, that is the actor smart contract. So in here, Atlas, all the smart contract functions right on top of actors. Due to this reason, it introduced as a Atlas smart actor platform. So then we proceed sharding based replication instead of full node replication. Data can be sharded and replicate with majority of nodes. So these are the major contributions of the raza blockchain. So these let's look at the architecture of the raza. So this is the high level architecture of the raza blockchain. So we built this raza blockchain also by using microservice-based philosophy. So in single node, it contains these 4 services. Each node have their own 4 services. So Loka service, Appless service, storage service, Raza ML service. Loka is the blockchain ready service. Appless is the smart contract service on the blockchain. Storage is the play all the blockchain assets, transactions, and blocks stored. Raza ML is a federated machine learning based machine learning service. It's about federated learning approach to build the machine learning models. It's a coordinatorless federated learning platform. So we use Kafka for the consensus. All the peer-to-peer communications also happen by Kafka. So we use distributed cache to guarantee some linearizable consistency on blockchain. In here, we mainly targeted this blockchain for permission blockchain environments. We don't support for public blockchains currently. So then Appless smart contract. So Appless is a smart contract platform on the blockchain. It's a functional programming and actor-based smart contract platform. It's about concurrent transaction execution by using actor-based concurrency handling. In here, actually, there are 2 types of concurrency handling currently: shared memory and non-shared memory. Shared memory is basically threads. We use shared objects to handle the concurrent access of this object. We use mutex or locks and threads. So that's the idea of the shared memory. And there's another type called non-shared memory. Non-shared memory also introduces actor-based concurrency handling. Actors are really alternative for threads. So actors are really lightweight. They use shared nothing architecture. They have their own memory space. So each actor have their own memory space. They can communicate with each other via message passing. So shared nothing architecture. They are really lightweight, and multiple actors can run parallel. So in here with the Appless smart contract, so we use directly actor-based concurrency handling. We implement with this smart contract platform by using Scala functional programming language, Akka actor framework. Akka is a Scala functional programming languages actor framework. In here with Appless, what we major thing we have done is all the smart contracts we write on top of actors. Instead of functions, they use messages. So that's the way we have built smart contracts. So all the smart contract write on top of Akka actors. So it introduces as a smart actor platform. So they can support concurrent transaction execution by using actor-based concurrency handling. So this high level how actors, smart actors work on Appless. So the client will be there. Kafka is the message broker and the consensus platform. All the transactions ordered on the Kafka. Then we stream those transactions to Appless smart actors by using actors, so they can execute and update the storage. So that's the high level workflow of the Appless smart actors. Okay, so let's look at the SaaS architecture, what we have done with SaaS and Appless. So in here, that existing blockchain systems, all the smart contract run on single monolithic service. In Appless, traditional Appless service also, all the smart contract run on top of monolithic service. So even though there are multiple smart contract with fully independent business logic, they run on a single monolithic container. So actually, it's a performance bottleneck during the processing a large number of transactions. That's one of the major performance concern on the blockchain. Due to this reason, it cannot achieve really high scalability. So to address this challenge, we adopt microservice-based philosophy or architecture into the blockchain smart contract. Microservice follows single responsibility thing, so with Unix philosophy. So we directly adopt this microservice philosophy in the blockchain smart contracts. So in here we propose now a architecture to run independent smart contract on a separate microservice. So based on the microservice philosophy, we redesign a smart actor framework on Raza blockchain. So this architecture introduced as a SaaS, smart actors as a service. So consider some scenario. This is the scenario that we propose with SaaS architecture. We design some document approval application by using SaaS smart contract architecture. So we propose some document approval application where multiple parties can share and approve documents peer-to-peer manner. So it's an alternative for traditional centralized document approval application. So anyone can, multiple parties will be there. Users can upload documents and they can define signers. So they can then signers will be notified. So they can fetch the document to their mobile application and they can sign those documents. That means digital sign as well as, and they can add their physical signatures onto the PDF document. It can use to automate the document approval process on organization, maybe on a process organization. In this application, there are three major actors or smart contracts. So basically document contract which handle all the document approval process, then account contract which handle all the user registration as basically user account handle, then notification contract because we use push notification to notify about the document to the user's mobile application. So in here all the notification functions handle with the notification contract. In here that traditional smart contract architecture, this is how that smart contract looks like. All the smart contracts run on a single monolithic container. There are three major contracts: account contract, document contract, and notification contract. We introduced the account actor, document actor, and smart notification actor. All the smart contracts run on a single monolithic container. So that's the main thing. So client submit transaction to the gateway, it will publish to the Kafka, it order the transaction on there. Then all the smart contracts so consume the transactions and execute on there. It's a single monolithic container on there. With SaaS, what we have major thing what we have done is we can deploy different smart actors in blockchain as a separate independent service. In traditional actors smart contract, all the smart actors basically run on single container. In SaaS, we decompose this independent smart contract and we run them on independent services. So all the smart contract in here we run with Docker containers. This ensures different smart actors can execute transaction independently. It supports concurrent transaction and produce high scalability. We prove the scalability and transaction throughput of the SaaS by in our evaluation. I will show more details in the evaluation section. This architecture increases scalability, support concurrent transaction execution, and produce high transaction throughput on the blockchain. So this is how that with SaaS this smart contracts looks like on the blockchain. So in here previously there are single monolithic container. Instead we with SaaS we decompose all the functionalities, all the smart actors into independent services. So there's an account actor service, document actor service, and device actor service. In here client publish transaction to here, it order on the Kafka. Then they can parallelly consume these transactions and achieve high scalability and transaction throughput. Another major thing is so we can support scalability and load balancing. We can run multiple replicas of these smart actors in that case. So for instance, account actor we can run two replicas, document actor we can run three replicas. In that case, all the that all the actors have their own Kafka topic which consume the transactions via Kafka. In that case, in partition that multiple replica environment, this Kafka topic can be partitions. In that case, this replicas group as Kafka consumer group and work with the partition Kafka topic. This is how it look like. There will be a partition Kafka topic, so we can run multiple replicas to against this partition Kafka topic. Based on the load, we can dynamically increase the number of replicas as well. So by using, so we can achieve high scalability and high transaction throughput by running multiple replicas of the smart actors. So finally, we have done a performance evaluation of the SaaS. So the evaluation mainly done with these five major areas: invoke transaction throughput, query transaction throughput, transaction scalability, transaction latency, and transaction execution rate. First, look at the invoke transaction throughput. Actually, there are two major transaction type on the blockchain: invoke transaction and query transactions. Invoke transaction do write to the ledger, that means state updates is there, and query transaction just read the status from the ledger, no state update involved on there. So this is how that SaaS and monolithic results look like. Actually, these results we mainly update in the previous document approval application. We build the document approval application using monolithic based architecture as well as SaaS architecture, and we get these statistics. In here, what we have done is we shoot concurrent transaction into the each blockchain peer and record a number of executed transactions. So in here you can see that each peer has consistent transaction throughput. That means SaaS architecture has around 900 to 1000 TPS, and this has around 60 to 70 TPS. So major improvement with SaaS is we achieve high transaction throughput in there. The major reason is so that it supports more concurrent transactions, since independent smart contracts, smart actors can run parallel, and also it can support multiple replicas of the smart actors can run parallel. Due to this reason, it achieves high high transaction throughput. So then query transaction throughput. So this is how query transaction throughput look like. So it has gained around 1700 TPS in the SaaS and 1100 TPS in the monolithic. Query transaction produce a high TPS when comparing with the invoke transaction because they just read the state from ledger. The major reason for high transaction throughput of SaaS is similar to the invoke transaction throughput is SaaS. So because that we can run multiple replicas, we can achieve high transaction throughput with SaaS. So then transaction scalability. So this is how transaction scalability varies. In here we increase the number of blockchain nodes in the network and measure the number of executed transactions per second. You can see that SaaS and monolithic how it differs. Since SaaS produce high transaction throughput per second, it achieve high scalability when comparing with monolithic based systems. Okay, so then latency, transaction latency, that means since it produce SaaS produce high TPS based on number of replicas, when adding number of replicas, so latency will be decreases than the monolithic architecture. So finally, we have done another major evaluation, transaction execution rate. I have mentioned that we can run multiple replicas of the smart contracts. For instance, in document smart actor, we can run multiple replicas, 3 replicas. In here, we calculate what are the executed transactions when increasing number of replicas. We get that measure against the time. So in here, you can see that 1 replica, 2 replica, and 3 replica. When increasing number of replicas, this is how transaction throughput varies against the time. You can see that when increasing replicas, it could achieve high transaction throughput. So that is the major concern with SaaS architecture by using scalable architecture with microservice-based philosophy. Okay, so these are the major performance evaluations we have done. We prove that how SaaS can achieve high scalability and transaction throughput instead of using monolithic based system. Okay, yes, so that's it from my side. If you have any questions, we can discuss them now. Okay, thank you very much for your time.